Hi guys, today we're going to learn about counting techniques. This is the first exercise in permutations and combinations. To find the probability of an event happening, we compare the numbers of ways the event can occur with the total number of possible outcomes, which is the sample space, and we use the formula: the probability of the event equals the number of ways the event can occur, or the number of favourable outcomes over the total number of outcomes. The hardest part of calculating probabilities is determining the total number of outcomes. This can become quite difficult when the numbers of outcomes are large. There are some counting techniques that help in this case. The fundamental counting principle comes from the product rule of probability to help us easily determine the total number of arrangements possible for a given situation. For example, Sarah picked 5 dresses, 2 necklaces, and 3 pairs of shoes on her holiday to Melbourne. If she chooses a dress, necklace, and pair of shoes at random, how many possible outcomes are possible? If you were doing this back in Year 10 probability, you would have most likely drawn a tree diagram in order to work it out. So when we draw our tree diagram, we have our 5 dresses along the top, our 2 necklaces underneath each dress, and then our 3 pairs of shoes underneath each necklace. But when we look at it, to work out how many outcomes are possible, we'd have to calculate our first outcome as being D1 times N1 times S1. Our second would then be D1 times N1 times S2 and D1 times N1 times S3, all the way up until we get to D5 N2 S3. Now, to count how many ways it is very tedious when we can just use, if one event can happen in P different ways and another event can happen in Q different ways, and the next event can happen in R different ways, then the 3 successive events can happen in P, Q, R different ways when we're multiplying this together. So if our P stands for our dresses, we have 5 of those, multiplied by how many necklaces we have, which is 2, multiplied by how many pairs of shoes we have, which is 3. So when we calculate this, 5 times 2 times 3, we get that would be 30 outcomes, or 30 different ways Sarah could wear her 5 dresses, 2 necklaces, and 3 pairs of shoes on her holiday to Melbourne. The fundamental counting principle is if one event can happen in A different ways, a second event can happen in B different ways, a third event can happen in C different ways, and so on, then the successive events can happen in A times B times C times etc. different ways. So, we have an example here. A number plate on a car has 2 letters followed by 4 numbers. How many different number plates of this type are possible? Well, we think about it like this. We have our letter multiplied by another letter. Multiplied by a number, multiplied by a number, multiplied by a third number, and multiplied by a fourth number. Now, order is not important in this case, and we can have repeated numbers and letters. So, how many letters we have would be 26, as there's 26 letters in the alphabet, and this occurs for both spots because we can have like a double A, for example. Then the number of numbers possible is 10 because we have 0 to 9. So we have 10 times 10 times 10 times 10. So this looks like 26 squared times 10 squared, which is equal to 6,760,000 different ways that this number plate is possible. Example 2. In a restaurant has 5 different types of entrees, 12 main courses, and 6 desserts. If I order any combination of entree, main, course, and dessert at random, how many different combinations are possible? So to work this out, we know that we have 5 different types of entrees. So we can have 5 types of entrees. Then you could have 12 different types of mains, and 6 different types of desserts. So all we do here is we multiply these together. So we have 5 times 12 times 6, which gets us a grand total of 360 possible different combinations. For 2b, it states, if my friend makes 3 guesses at which combination I will order, what is the probability that he will guess correctly? In this question, a key word is probability. So we already know that he makes 3 guesses, and we also know that our probability, or our how many different combinations are possible, is 360. So the probability that he will guess correctly will be our 3 guesses over our 360 combinations, which when we enter this into our calculator equals 1 over 120. And finally, for example 3, we have, to win a trifecta bet in a race, a person has to pick the horses that come 1, 2 and 3 in the race in the correct order. The Melbourne Cup has 24 horses. How many different trifecta bets are possible? So we know that we have to have a horse that comes first, multiplied by a horse that comes second, multiplied by a horse that comes third. Now this horse that comes first, there's 24 horses that can come first, but the horse that comes first cannot come second. So that means that there's only 23 horses that can come second. And the horse that comes third cannot be the horse that came first or second. So there's only 22 horses left that can come third. When we multiply our 24 by 23 by 22 together, we get a grand total that is 12,144 different trifecta bets which are possible. This is the end of explaining counting techniques. If you were following the Maths in Focus by Margaret Groves Mathematics Extension 1 book, you would now complete exercise 301.